Greetings, gentlemen. Just hold tight while I'm taking attendance as I let you guys into the room, and then we'll get started. I'll start with like some announcements and updates, and then I will go from there. So, for instance, I have. Okay, I think I know who that is. Wow, that's an interesting name. That's very close to a famous comedian, one of my favorite comedians. I don't know if we have any females in here or not. I can't tell. Some of the names seem like they could be female, but I'm not really sure. Because I just want to acknowledge the females if they're here. Because I don't want to be like calling the entire group gentlemen when it's not all gentlemen. But that's yeah, but that's okay. Okay, I think we got one more and well a couple more. We got somebody else joining. All right. Go ahead. Go ahead. Hmm. Okay. Yeah. Just go ahead and do the 14-day trial period so that because you don't want to wait. Like that's not a good idea to wait. Okay. Go ahead. Hmm. Yeah, but not right now because like this is college algebra. The tutors can definitely help you with that. I can help you with that too because I teach that course. But just it's just that right this second I'm focused on like college algebra. That's what the time is allotted for. But the tutors, I don't know. I would say contact the math office, like, and ask them how to contact the tutors. Any professor can help you with that, and the tutor should be able to help you with that as well. Yeah, and I can help you with that too. Okay, I'm gonna mute the audio for a moment, just so I can get my announcements out. If you have questions or if you need attention, either like raise your hand or just type in the chat. I do monitor the chat. Matter of fact, we have some activity in the chat. Let me check it real quick. Yeah, I realized that was you. I think you have to change it before you log in. So like when you log out, instead of like after the class is over, instead of joining a session, you should be able to change it at that time. Um, it could have some cross-register students. I'm not really sure. Yeah. So we are doing asynchronous. So once you get into my Zoom, then that means you've got an attendance credit. If you get into my Zoom and there's any kind of attendance discrepancy that I'm aware of, I usually try to bring it to your attention immediately. But yeah, once you get into my Zoom, you've got your attendance credit. We are doing asynchronous, so you don't have to stay. That's on any given day. Um, these sessions are being live streamed to my YouTube. I did record the session from earlier with my students. Let me make sure I am streaming. It looks healthy, and I did get my notification, so that is good enough for me. But yeah, these sessions are live streamed to my YouTube channel. I have my link to I have the link to my YouTube channel posted in several places. Like there's a link on my Blackboard page. The first assignment, is a prereq that you at least have to get into the playlist. So I have it a couple of places, but my YouTube is Beautiful Mind Pfeiffer. And it's just basically I'm just using it as a catalog of like my interactions with students throughout the years. Sooner or later, I'll sit down and actually like put some time into presentation. I'm just using it as cloud storage to say the least. Things that are important. The main thing that's most important right now is that you are making your way through those assignments on Pearson. In the past year or so, Morehouse has revamped how they do college algebra. So the workload that you all are responsible for is drastically reduced from what your colleagues of the past had to do. What we're doing in 1 week, I think the students of the past had like one day to do that. What we're doing in like 2 or 3 weeks, they were responsible for in like 1 week. So, just to try to put a little bit of perspective on it, and I don't I don't want you to get lax or anything like that. But the main thing is just make sure that you're making your way through the assignments. As far as Pearson is concerned, I've only made the homeworks available. I do intend to go ahead and load all of your quizzes for the semester, and the exams are going to become available closer to the exam time. I'm kind of stalling also to give students a little bit of time to get in. HIJ, I think it was this student. Trying to think. Yeah, the main thing is just that you're making your way through those assignments. So like I am getting a little bit ahead of my lectures. Like earlier today, I did section 1.3 with my students, which is like next week's presentation. So I'm actually going to go ahead and start working on section 1.4. If you feel intimidated or you're not ready for section 1.4, it's totally okay. I would say just like go ahead and start making your way through section 1.3, the audio. Weeks at week 4, we can anticipate. Let me see. I think week 4 might only be 3 sections. I still want to go ahead and do the video because because it's a recording, we can go back and watch it as we need it. I'm okay getting a little bit ahead. Again, I just ate breakfast, so I had to kind of rush a little bit to get it in there, but so that's what this is. But I can't think of anything else. There was something I was going to say. I keep losing my train of thought. But yeah, I am monitoring the chat. I did mute the audio for right now just so that I can focus. So if you have a question or a concern with anything, either raise your hand and it'll create a notification that I'll see, or type in the chat and I'll get to you momentarily. Okay, I'm gonna quote unquote assume that everything is clicking properly, and we're gonna go ahead and get the party started. Okay. So, like I said earlier, with my students from earlier, I went on and did section 1.3 that was concerning functions. So this is section 1.4, a library of functions. So this is a little bit ahead. It's okay. You don't have to listen to this right now. I'm just creating the video so you guys can have a fresh version of this material. Next week, we're really supposed to be starting on section 1.3, and then the week after that might actually be exam 1. That's why I'm hesitating. Exam 1 occurs in week 4. Exam 2 is week 8, and exam 3 is week 12. So, but I'm just going to go ahead and do this anyway, just so we can have it on file, and we'll watch it as needed. Okay? Let's see. So section 1.4 is a library of functions. Some objectives here: we want to define linear functions. We want to discuss important properties of functions. We like to graph square root and cube root functions. We like to evaluate and graph piecewise functions, graph basic functions, and find the average rate of change of a function. Also, as you sit down and watch any of these lectures, and I want to say these lectures are already recorded. Like it's essentially the same thing I did with the students in the spring. I just got the gumption to make a fresh version of these videos. But as you make your way through any of the videos, and you want to go in chronological order or sequential order, but as you make your way through the videos, it's a good idea to take notes as if you're in class. So have a notebook. The name of the game here is like organization. The more organized you are, having clean notes, having your homework written out and available. You can just submit your homework via Pearson, but that's for your own reference, right? You want to have that stuff written out, a copy of it, where if you get asked the same question again, you can quickly flip to it and have a similar version worked out. So the more organized you are, the better your life will be. If you don't want to be organized, that's just another path, and it's okay. I don't recommend it, but everybody has their own path to walk. There was one other thing, but I think it slipped my mind, so I'll have to wait until it pops back up. It wasn't the homework. It wasn't this. Okay, it'll pop back up when it needs to. All right. So then linear, let's start by exploring linear functions. So let m and b be real numbers, then the function f of x equals mx plus b is called a linear function. If m, which is the slope, is equal to 0, the function f of x equals b is called a constant function, right? So that first term was going to go to 0, And then f of x equals b is called a constant function. Let me get my cursor. And let me actually do this one. If the slope is equal to 1, no, I'm not liking that. Switch this back. And b equals to 0, so if the y-intercept is 0, then the resulting function is called the identity function. So we have f of x equals x or y equals x, right? So, we kind of introduced function notation in section 1.3. So just kind of go with it for right now. And then, the recording for section 1.3 is already available. And I did it earlier today. I'm just kind of moving forward. You can always go back and listen to things in a proper order. Okay, let's keep going. So the graph of f of x equals mx plus b. The graph of a linear function is a non-vertical line with the slope m and y-intercept of b, right? So these are just examples. Basically, it's just graphing a line on the xy plane. Notice that when the slope is positive, as we trace the graph left to right, the graph goes up. If the slope is negative, as we trace the graph left to right, the slope goes down. Okay, let me check the chat. Let's see what's going on here. Yeah. So again, once you get into my my Zoom, because I take attendance as I let you guys in. So once you get into my Zoom, that means you've already gotten your attendance for the day. So and we are doing asynchronous. So I totally get, I just want to encourage you guys to do the best you can to get your assignment submitted. I know this stuff can be a little bit intense, especially the way I talk, the rhythm I talk. But I feel like because it's a recording, you can always step back, take a breather. If you need to sit down with the tutor and make your way through the stuff, I think that's a good idea. Also, let me do some other announcements. So also, it's a good idea to seek the tutors. Remember, you've already paid for tutoring. I think this is College Algebra 1 without lab. So, you don't have the lab component, but you definitely want to seek out the tutors and take advantage of them. It was a tutoring. We talked about Pearson is already there. You can get ahead. Every time I get ready to say it, I don't say it, and then I forget it. Let me think about it. Hang on. It wasn't a tutoring. It wasn't getting ahead. Okay, I think what I was going to talk about. I did update Blackboard, right? I made several updates to Blackboard. Like I did an updated syllabus with like proper information. So if you want to fill out the last page of the syllabus and submit it, I made a Dropbox folder in Blackboard. It's like folder number 8. It says Dropbox. You should be able to upload your documents there. Also, anything that you see me writing, I made available in Blackboard. That's going to be folder number 7. It's going to be called like BoxLink or something like that. But I'm making basically all the stuff that you see me writing. You actually get a copy of it. So write what you feel like you need to, but you can actually pull a copy of all the stuff that you see me writing. I also went on and made like some documents for my students in the spring. I made that available. I just made several updates on Blackboard, just like with updated information. Okay, I think that was the thing I was trying to get out from earlier. Okay, let's keep it moving. I think the chat is okay. I don't see any notifications there. So we're going to explore some more graphs of f of x equals mx plus b. So I think we mentioned something where if the slope were 0 and we're considering f of x equals b, that's called the constant function, which is basically a flat horizontal line. It has a slope of 0, right? So when the slope is 0, we have a flat horizontal line. Say the y-intercept is 0 and the slope is 1. This is called the identity function, where we have f of x equals x. It's basically just a diagonal line through the origin. Right? That's the first function of our library of functions that we want to explore. So in this example, we're asked to write a linear function g where g of 1 is 4 and g of negative 3 is negative 2, right? So if we're asked to write a linear function, it's a good idea to start with the linear model, right? Which is going to be f of x equals mx plus b, right? So we have two ordered pairs. We're given g of 1 equals 4. We're also given g of negative 3 equals negative 2. Okay. So these are just two ordered pairs. The first ordered pair, when x is 1, y is 4. The second order pair is when x is -3, y is -2. Okay, so these are the order pairs that were given. It was just given in a different notation, but it means the same thing. So I don't know if you remember from last time. I'm a fan of whenever I get an order pair, I like to just go ahead and label it the following way: x1 y1, x2 y2. So whenever I get order pairs, I just label it. That makes it easier for me for identification for later. Okay. So if we want to model these 2 points to a linear model, right? We basically want to find the line that passes through these 2 points. So I think last time I also mentioned something about whenever I'm working with lines, there are 3 equations I like to have ready to go, right? So the first equation is the slope formula. That's the change of y over change in x, which is y sub 2 minus y sub 1 over x2 minus x1. Right, so the slope formula I like to have available. I also like to have the point slope formula and the slope intercept, right? I'm not going to write those here. I want you to kind of dig and find those in your notes. But whenever I'm working with lines, I usually try to have those 3 formulas ready to go. I think also last time I mentioned something about, it's a good idea to have a formula sheet. So every time you come across a new formula, update your formula sheet with that new formula. And so then if I were working with lines, I just have those 3 ready to go. So I was saying that because it's a good idea. Let's go ahead and find the slope. Let's go ahead and find the slope between these 2 points, right? So the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, this is the slope formula, right? So then if we plug in, I'm going to continue over here. So then my slope is going to be equal to, what's our y2? y2 is -2 minus our y1 is 4. Notice my use of parentheses around that negative. x2 is -3 minus x1, which is 1. Okay. Hopefully this is okay. Let's use some algebra or arithmetic. So on top we have -2 minus 4, so that's going to be -6. On the bottom, we have -3 minus 1. That's going to be -4. Double negative is positive. These both have a factor of 2, so you can divide the top and bottom by 2, and we'll be left with 3 by 2, a positive 3 by 2. That's the slope, right? And I'm just going to highlight it like this, right? So we found our slope. So now let's take the slope and let's just choose one of the points. I'm going to choose the first order pair because it doesn't have any negatives. I feel like the negativity just complicates things, just like in life. Now, don't get it twisted. You know, if everything was all positive, then things wouldn't work properly. Think about it. If a battery was only positive and it didn't have the negative, would it work? If everybody was tall, how could you appreciate tall if everybody was the same height? If you didn't have short people, how could you appreciate one height over another? If everybody was the same, if you didn't have that contrast, how could you appreciate something if everything is the same, right? So, you know, one side of the coin is not better or worse than the other side of the coin. It just creates a contrast so that we can like have a level of appreciation. Not to get so deep. I'm trying to find this student and I am not seeing them on my roster. I'm hesitant to let them in. They might be in a later class. All right, let me unmute and I'm gonna try to talk to the student. All right, let me give it a moment to load because I know sometimes the audio, and if I have trouble, I know exactly what to do. Let me check the chat. So I just let a student in whose last name is Lee, Mr. Lee. I don't have you on my roster for this time, right? I'm not sure if you're in a different time slot or not. I usually don't let students in my class if they're not on my roster. I'm just letting you know so that you don't think that you're on my roster. You're not on my roster, right? So, okay. Okay. I just wanted you to know so that, like, you know, on my end, I just didn't see it. So maybe it'll be different tomorrow or next week or something like that. Okay. So I just wanted to bring that to your attention. Okay. Yeah. So I'm gonna mute the audio again. If you guys have questions, comments, or concerns, feel free to type it in the chat or raise your hand, and I'll be checking back in momentarily. Yeah. So negative isn't always bad, right? I can think of some other examples, but I'm gonna leave it at that for right now. Let's see. You know, write a linear function. Okay, so we have the slope. So again, I'm just gonna choose the first order pair because I just don't want to deal with the negatives. Like I feel like it complicates things. Okay. So where is it? Okay. So then if my y is 4, let's write it this way. We said the slope is 3 by 2. Let's do this. The slope is 3 by 2. If we're choosing the first order pair, the x is 1. We don't know what b is yet, and our y, when x is 1, y is 4, right? So notice, so I plugged in the x from the first point, the y from the first point, and the slope that we found. The only thing we don't know is b, so I'm going to go ahead and solve for b. So then b is going to be equal to 4 minus 3 halves. What is that? 8 over 2 minus 3 is 5. 5 over 2. Keep in mind, you can use calculators. I'm just working my mental muscle. You know, I go to the gym and I just start thinking really hard, like get my mental reps up. You gotta exercise that mental mind. You know, whatever we practice, we get really good at. You know. Anyway, so we got our slope, we got our y-intercept. Just making jokes, just trying to be light and keep it light, because you know life is hard enough as is. You don't need math or my energy to bring it down. Math is a beast by itself, right? All right, so then the function that we get is g of x ends up being our slope, which is the 3 by 2 times x plus 5 by 2. Now we got this result. We need to confirm that this works for both order pairs, right? So we just basically need to check. Okay, that looks better. I'm gonna go like this, style. I'm gonna make this a little bit bigger and neater. Give me just a moment. I think that's everything that I need. Darn. Let's start from here. It's getting close. Oh, okay, I'll just put that back. All right. And we got this result. Okay, so then I'm just gonna do a quick check, right? So when x is 1, y should be 4. So if we plug in 1, 3 over 2 plus 5 over 2 is 8 over 2, which is 4. So that one checks out. When x is negative 3, y is supposed to be negative 2. So negative 3 times negative 3 is negative 9 over 2. Negative 9 plus 5 is negative 4. Negative 4 over 2 is negative 2. Okay. Again, you can use your calculators. I was just practice doing this mentally, just to practice, just for the sake of practicing. Okay, I'm confident in this. I think we have this already prepared, right? So we have a type version of the work we just did. You see the slope formula there. They got the same slope that we got. Now they use the point slope, and I'm glad they did that. They chose a different route, but they get to the same conclusion that we did. And point slope is appropriate. I mean, you use it when you're given a point and a slope. I just prefer doing it the way that I did it. So with all of this stuff, you're going to find that there's more than one correct way to go about these. You don't have to know all the correct ways. You just need one correct way that works for you for these different concepts, all right? So as long as you can find a way that works consistently, you're good to go, you know? And you just basically, you discover these through experience and engaging with people with different perspectives. The truth, math is all about the truth, and the truth is one of those things, it can't be told. I can't tell you the truth. I can't tell it to you. The truth is something that has to be realized, right? So I'm only here to kind of point you in a direction and kind of nudge you on your way, but it's something that you have to realize for yourself. I can't tell you, because I've tried. With my loved ones, I've tried telling them what I think to be the truth, and we fight about it, and I'm just like, I realize, I can't tell them anything. I can only suggest, and they can suggest to me, and the truth can only be realized, never told. Okay, moving on, getting off the soapbox. So we want to move. Let me check the time. We started at what, 2? We're moving and grooving. I'm sorry, I'm getting these random notifications from like YouTubers doing like these little short, witty videos. I'm looking at something that this person was talking about, knees stronger than Megan Thee Stallion. And so it's like, I guess it's like people, doing crazy stuff and just not being fit for what they're doing and just looking really funny. Anyway, okay, like this crate challenge is like, I don't know how to feel about it because you want to see the people make it, but then it's like we don't have nothing better to do than like hurt ourselves trying to walk up some flimsy crates. We're like, please, Lord, bless the children. But it is what it is. It's just one of those things. Okay, back on task. So this next topic is called, we want to look at this notion of increasing, decreasing, and constant functions. So we want to let f be a function and let x1 and x2 be any two numbers in an open interval ab contained in the domain of f. Then the symbols a and b may represent non-real numbers, negative infinity or infinity. Then the following is the case. We said that the function is increasing on the open interval if whenever x1 is strictly less than x2, this implies that f of x1 is strictly less than f of x2, right? So let's see if we can so given some open interval AB, we consider some x1 less than x2, then when x1 is less than x2, we have f of x1 is less than f of x2. That implies that the function is increasing, right? That's kind of a mouthful, and we'll have a more simple way to kind of articulate that, but this is like a more formal articulation. We say f is a decreasing function on an open interval AB if whenever x1 is less than x2, that implies that f of x1 is now greater than f of x2, right? So we have x1 is less than x2, but notice that f of x1 is greater than f of x2, right? So that's what we mean by a function is decreasing. And then we say a function is constant on an open interval AB if whenever x1 is strictly less than x2, this implies that f of x1 is equal to f of x2, right? So that's a formula articulation. Let's see some examples where we can kind of make this more simple. Math is all about simplification. Keep it simple, silly, right? So from the graph of G, find the intervals over which G is increasing, decreasing, or constant, okay? So as we trace this graph from the left to the right, let's use a different color. As we trace this graph from the left to the right, what is it doing up first? Is it going up, is it going down, or is it staying flat, right? So as we trace it left to right, initially it's increasing. So we're going to say that it's increasing. Now the far left, how far left does this graph go? The far left is negative infinity. And it's increasing all the way from negative infinity up until x is what? Negative 2. Infinity always gets a parentheses because we never reach infinity. For increasing, I'm under the impression we should always use parentheses for this discussion of increasing, decreasing, and constant because it has to be defined on an open interval. Next, as the function goes from negative 2 up until what is that? X equals 3. Notice the graph, is it increasing, is it decreasing, or is it constant? As we trace it left to right, is it going up, is it going down, or is it staying flat? Right? So as x moves from negative 2 to 3, the graph stays flat. So we're going to say it's constant as x goes from negative 2 to 3, and we just use open intervals here. Then as we continue to trace the graph from the left to the right, I feel like we're going on an adventure. As we continue to trace the graph left to right, is the function increasing, decreasing, or is it constant, right? As we trace it left to right, notice the graph is going down, okay? So we say that the function is decreasing as x moves from 3 and the far right. How far right does the graph go? Notice there are arrows, so it just keeps going. How far right does the graph go? Got people stunting out here. The far right is going to be positive infinity. Again, infinity always gets a parentheses, and for this discussion of increasing, decreasing, and constant, I think it generally gets a parentheses as well for this discussion, okay? So these are the results that we got here, okay? And I think we have these results already typed up as well. Come on. Ugh. Let's delete that, and let's do like this. I know this will work. So I'm just going to put this here. Style. Okay. Let's see the time. I do need to go get some water. I'm going to power through. Okay. So we said it's increasing from negative infinity to -2. It's constant from -2 to 3, and it's decreasing from 3 to infinity. Okay, let me check the chat to see if there are any questions, comments, or concerns. Oh, those numbers are dwindling. They're falling off. They're dropping like flies. That's generally what happens. But it's okay. It's okay. Like I had to realize to just move to asynchronous. That's exactly why I do asynchronous though. These sessions are recorded, and when people are ready, the information is there. Again, if this does seem like a lot of information, I would recommend sitting down with the tutor and going through it with the tutor, or maybe like a study session, like y'all get together, like, hey, can we talk about this stuff? Yeah, because I generally have a sense of how it goes with my interactions with the students, not to try to like, I don't really know what's going to happen, but my dog is like faithfully waiting for me to drop some food for her here. She's so funny. Like most of the time, she ignores me, but if I got food, she's had my undivided attention the whole time I've been talking. She's just been sitting there staring at me because she knows food on this table. It's so funny, hilarious. Okay, so let's look at this next topic. So here we want to look at what do we mean by relative maxima and relative minimum. If A is in the domain of a function, here, let me do it over here. If A is in the domain of a function f, we say that the value f of A is the relative minimum of the function f. If there is an interval x1 to x2 containing A such that f of A is less than all f of x for every x in the interval, in this open interval. We say that the value f of A is a relative maximum of f if there are any interval, basically the same thing, but where that f of A is larger than all f of x, right? So that's a little bit of a mouthful. I feel like it's easier to see in this slide, right? So examples of relative maximum, this point here, these are examples of relative maximum. These are going to be the f of a's that are larger than all nearby f of x's. These are examples of relative minimum. These f of a's would be lower than all nearby f of x's, right? So basically, a relative minimum is going to be like the bottom of a valley, and a relative maximum is going to be like the peak of a mountain in a graphical sense. Okay. Okay, moving along. So we said that a function is called an even function if for each x in the domain of f, negative x is also in the domain of f. And then we have f of negative x equals f of x. So this is something I would actually add to the formula sheet. I would say even function f of negative x equals f of x. I would add that to my formula sheet. The graph of an even function is symmetric with respect to the y-axis. Okay, so the definition of a function being even means it satisfies f of negative x equals f of x, right? So if an even function is identified as f of negative x equals f of x, what do you think an odd function? How do we identify an odd function? How can we change this, right? So even means f of negative x equals f of x. An odd function means f of negative x equals negative of the original, right? So a function is an odd function. I would add this to my formula sheet. A function f is an odd function if, for each x in the domain of f, negative x is also in the domain of f, right? So f of negative x equals negative f of x. The graph of an odd function is symmetric with respect to the origin. So even function has y-axis symmetry. Odd functions are symmetric with respect to the origin. Okay. I don't want to keep you for more than 10 minutes. I more than likely won't finish this presentation in 10 minutes, but I will stop and let you go at 10 minutes. But let's just kind of keep going. But I'm going to continue to stream because I want to just have a full, clean, fresh copy of this information. And we're about a third of the way through all the slides. Okay, so in this example, we're asked to determine whether each function is even, odd, or neither, right? Okay, so this is how I like to go about this. So for part A, all I'm going to do, I'm going to evaluate g of negative x. I'm just going to do g of negative x. First, I'm going to replace, when I do my substitutions, first I'll replace each x with a blank set of parentheses. So I'm going to say x cubed minus 4x. right? And then what goes into the blank parentheses in this case? What color? We're plugging the blue thing in to the blank parentheses. Now we're going to use algebra to simplify. So if we have 3 negatives multiplied, is the final result going to be positive or negative? Negative times negative times negative is ultimately negative, right? Double negative is positive, right? Notice that this is not the original. Is there a way we can get back to some form of the original? It looks like if we factor out a negative from all those terms, let's factor out a -1, we're going to be left with negative times x cubed minus 4x. Notice that this is indeed negative g of x. So this is negative of the original. So we have g of negative x equals negative g of x. So then that's how we identify a function as being, that means this function is odd. Okay, let's do another one. And actually I'm going to shrink this down just to fit it under part A. Okay, I'm going to just shrink it like right here. And again, all the stuff that you see me writing, I'll make a copy of it available as soon as I'm done. And you can actually access these PDFs on our Blackboard page. Okay, just contact me if you're having trouble finding that. For part B, again, we're going to evaluate f of negative x. Okay. I'm going to replace each x with a blank set of parentheses. And then what goes in the blank parentheses here? Negative x. Okay. So now we're going to use arithmetic or algebra to simplify. Negative x times negative x is positive x squared plus 5. Is this the original? This is indeed the original. We're going to say this is equal to f of x. So when you have f of negative x equals the original, that's the definition of a function being even. That's how we identify a function as being even. Okay. And just like the previous one, I'm going to shrink this down so that it fits under part B, just for economy of space. Like that. Okay. And then let's go ahead and work on part C. Same thing, we're going to do h of negative x. We're going to replace each x with a blank set of parentheses. This one's cubed, this one's squared. And inside the blank parentheses, we're going to do negative x. Negative x. We're running a little bit short on space, okay? So I'm going to kind of move over here a little bit. So for that first term, if we have an odd number of negatives, oh, he made it, cool. This is him, yeah. I'm being a little bit lax as far as the time for this for right now, just because, you know, I get it, it's okay. So if we have an odd number of negatives, that final term is going to be negative. So we're going to have a negative 2x cubed. If we have an even number of negatives, the final result is going to be positive there. Is this the original? This is not the original. Even if we factor out a negative from all the terms, we can't get negative of the original. So this is an example of something that's neither even or odd. Neither. This is neither even nor odd. Okay. Okay, let me see the time. I think we got 5 minutes. I only want to keep it for like 5 more minutes. Let me go ahead and do one more example. I see the chat activity. Give me just a moment. I think we got those correct. So let me at least get to the next example. We have some notation here on evaluating a piecewise function. All a piecewise function is, it's just several graphs on one plane, right? And each graph is like restricted to a certain domain. So determine which line of the function applies to part A, and then evaluate the function chosen in step 1. So for instance, before I do this one, I'm going to check the chat because I know I saw some activity there. Oh, it's no worries. Yeah, I got you for attendance. I had my own issues earlier with my students from earlier. It's okay for right now. Just you're here, you got your attendance credit. The main thing that I request is that you guys get your assignment submitted promptly as possible. And also, as you're making your way through the Pearson assignments, if you get stuck or if you feel like you can't get any help, click on the help me solve this. Click on the ask my instructor, and it sends me a screenshot of your question. I've already responded to one student that did it. I'll load your question onto my tablet. I'll make a dedicated YouTube video and I'll send you the link. And I usually make these available, so that's why you want to be subscribed to my YouTube with your notifications turned on. It's free tutoring. Honestly, once you get into my YouTube, I don't charge people for it. I do work on donations, not for you guys. You guys have already paid because you're my students. But even like leaving this class, as long as you can get on my page, it's free math tutoring, essentially. And I teach from Calculus 3 on down and a few courses beyond Cal 3. Okay, so let's look at this piecewise function. Let me see the time. Yeah, we got time for this one. So consider this piecewise function. Let f of x be this piecewise, right? It's basically two functions in one. The first function is y equals x squared, but that only applies when x is less than 1. The second one is the linear function 2x plus 1, but that only applies when x is greater than or equal to 1, right? So then this says find f of 0 and find f of 2. So let's consider f of 0 first, right? So if x is 0, do we use the first line or do we use the second line? If x is 0, notice that 0 is to the left of 1, right? 0 is less than 1, so that means that we're going to use this first line. So that means we plug it into the first one, okay? So then f of 0 is going to be 0 squared, which is 0. That's it. Right, you just got to identify which line of the function are you going to use. For the second part, that asks us to find f of 2. So if x is 2, are we using the first line or the second line? Notice that 2 is larger than 1, so we should use that second line. So we're going to say 2 times 2 plus 1, which is 5. Okay. So the first one we got 0, the second one we got 5. And here we have a typed explanation of what went on. Okay. We got 0, we got 5. Let me check the chat really quickly. The time. Okay, let me keep going. Just no, I'm going to do my best to stop at like 2:45. Given this piecewise function, sketch the graph. Okay. Let me give myself some graph paper. So I'm going to go like this. Like this. There we go. That looks good. Go away. Come on. Paper. I want like this for right now. Come on. Are you slowing down on me? You sure are slowing down. Come on. I don't need you to slow down right now. Okay, give me a moment. I'm going to reboot this. I think I got time to do it. Give me just a moment. Let me see the time. We're working here. Let's go view, single page, and let me get back to where I left off from. I was like on 20. Trying to do the graph paper right here. Okay. All right, so did I? Okay. Paper, graph paper. All right. Hopefully I can get this. Oh, it still lagging. Shyster. That totally did not help. Okay. I'm going to try it really quickly. I'm watching the clock. This is going to be my positive x-axis over here. You can go like this for the positive y. Okay, that looks good. So x is here, y is here. We're talking about 1. Okay, so I'm just going to put some tick marks. 1, 2, 3. Let's make that a little bit bigger. That's the half. That's 1, 2, 3. I think that's enough. 1, 2. Watching the clock. That's 3. 1, 2. Hopefully that's enough. 1, 2. So this is the origin. I'm doing it like this is 1, 2, 3. 1, 2. 1, 2. These are negatives. 1, 2, 3. These are negatives. Okay. Let me see the time. All right, I'm going to wrap this up. So the first one, let's do the first one. Let's do blue. About to get you guys out of here. So I'm going to see the clock. Style, fill. I want that same blue. Stroke is that same blue. Why does it look different? Okay, I think I know what I did wrong. Right there. Okay. So we're going to do this first one in blue. So it's basically, it says it's a line, okay? The y-intercept is 1 and the slope is 2. So if we go, it's -2. So if we go down 1, down 2 and right 1, 1, right 1 is here. But this only applies when x is strictly less than 1. So this would get an open circle here and then a straight edge like that. I'm going to do a rough sketch just because I'm kind of short on time. I'm not trying to get you all out of here. Partial, kind of like that, right? Okay, so it's supposed to be something like that, open circle, because it's not defined when x is 1. Let's do the next one. Let's do orange. Come on, copy, paste. Okay, oh, that's fine. Style. We're gonna do that one in orange, and stroke is in orange. I'm watching the clock. Let's see. The y-intercept is 1. Oh, and the slope is 3. This, oh, it's kind of going off our chart. We need to adjust our chart. But I don't think we have enough space. If we go to 1 and the slope is 3, 1, 2, 3, so it's going off the chart. It's like a straight line that's up here off our chart, so we should have shifted up some. I'm just going to leave that sketch for right now, just because of the sake of time. But we have this paper, so let me show you where I was getting at. Right, I just did a quick sketch because of the time. Okay, graph the function. We have a type version. I'm just going to kind of jump to the result. So you see where you have the open circle. You have those components here on the left. This is where we needed to go a little bit higher. So you see this on the right, and then you put those two pieces together, and this was the image that I was going for. Okay, that brings us about halfway through. Okay, so with that, I'm actually going to let you guys go. If you have questions, just type in the chat, and I'll unmute as needed. You don't have to stay. You're welcome to stay if you'd like to. I am going to continue streaming, and I'll be back. I'll let my next students in momentarily. It's streaming on my YouTube right now. So as soon as I stop streaming, whatever I'm talking about now is going to be available. So yeah, it'll be there. Yep. Okay, so I'm just going to keep going. So now, this is called the greatest integer function. And again, you're welcome to stay if you like, and feel free to leave as well as needed, per your prerogative. So this is called the greatest integer function, but there's a typo here. Let me correct the typo. So the symbol, the greatest integer symbol, it doesn't look like that. It looks more so like this. You have your x, and then it's like a bracket here. It's like a double bracket in this fashion, right? That's the greatest integer function. So we're asked to graph the greatest integer function. For the sake of time, I'm going to use what's already prepared. But before we get into that graph, I want to kind of walk you through a brief visualization. So greatest integer is the greatest integer less than or equal to some number, right? So basically what we're saying is, like whenever we have a decimal, we take the integer to the left of the decimal. Whenever we get an integer, we take that integer. So for instance, what do I mean by that? the greatest integer less than or equal to, say we started at, let's start at 2. All right, the greatest integer less, so whenever we get an integer, that's just going to be the integer itself. All right, copy, paste. So let's consider, copy. So that was 2. Let's consider, let's consider 2.1, all right? What's the integer less than or equal to 2.1? That one is still 2. Okay, let's do 2.5. What's the integer to the left? If you look on the number line, 2.5 is between 2 and 3. The integer to the left is still 2. Let's consider 2.9. All right, the integer to the left is still 2. Let's consider 2.999999999. Right? What's the greatest integer to the left? Still 2. Right? Let's consider 3. Again, whenever we get an integer, we take that integer. Right? Can you see the pattern there? Right? So if I did something random, let's do one more for the 3's. Right? Say we did, I don't know, 3.27, blah, 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 blah. Integer to the left is 3, right? Okay. Let's consider, what if we did 0.5? What's the integer to the left? The integer to the left is 0. Let's consider, what if we did 0.1? What if we did 0.001? Let's clean that up a little bit. What's the integer to the left? The integer to the left is still 0. What if we do, let's do negative 0.5. What's the integer to the left? So if you look on the number line, negative 0.5 is between negative 1 and 0. So what's the integer to the left? Integer to the left is negative 1. Okay. So let's consider negative 0.99999. What's the integer to the left? Negative 1. Okay. Let's consider negative 1. Remember, whenever we get an integer, we just take that integer. Okay. Let's do this. We're almost there. Let's consider negative 1.001. Right? What's the integer to the left? This decimal is between negative 2 and negative 1. The greatest integer less than or equal to this is actually negative 2. Right? We're always taking the integer to the left, right? Hopefully you can see the pattern with that little exercise. Okay? Okay, with that being said, I think we have what we need to get through the next couple of examples. Let me see the time. So I know my next time. I might take a 5-minute break for myself so I can get some water. Let me at least finish this concept. So again, that symbol did not display properly. It's just technology, being technology. But again, it's supposed to look like this with an X. And I'm just going to shrink it down and just kind of put it like here. Okay. So basically, they're kind of like plotting points. They're choosing several values of X, finding the corresponding Y. And when you plot the points, it'll essentially look like this. And again, the symbol is this guy. Okay. So the piecewise function looks like this when you plot it in a normal sense. And we call this like a step function. It looks like the stairs on a ladder. Remember, the closed circles mean that it's valid at that point, and the open circle means that it's not valid at that point. Okay, I see my students for the next class coming in. I'll probably let them in as soon as the time starts. I might take a 5-minute break just so I can get myself some water. Yeah, I'm going to pause right here. I'll be right back. Okay, I see we still got people hanging. Hang tight. I gotta get some water. Let me the thing is, let me go ahead and pull up my go to the waiting room here. Oh, actually, yeah. Let me do the waiting room. I need to go ahead and pull up my attendance for my next class as well. Whew, man, all this talking. Hope that. Let's go Blackboard. Let me check that last one that we just did. Okay. Like I just got to mark these students that I didn't see. It wasn't that many. The turnout was decent today. Okay, that looks good. And then this next course is right here, not that one. It's this one. It's just 3 o'clock, right? Yeah. Okay. There we go. Okay, that looks good. And let's hop back here and put this back here. Okay, that looks good. And let's let these students in. Okay. Okay. So 1, 2. So I'm just taking attendance as 11 students in, and we're gonna kind of keep moving and grooving. I don't know who the student is. There he is. Yeah. Okay, I'm gonna let. So I need to make a quick announcement. So as you guys come into the room, I'm trying to wrap up what I was doing with the previous student, the section that I was working on. If you're not showing your official Morehouse student name, you definitely want to update that so that you're showing your Morehouse name. Like one of the students, I think I gave him the credit to the right person. You know, I chose the name that was the closest. That may or may not be that student. So you just want to make sure, like if it's on Zoom, you want to just have your student name showing, just for the sake of being professional. You just have to kind of, you know, change it each time, or just go ahead and put your student name, and then once you're done with the Zoom stuff, then you can do nicknames and things like that. But just hang tight. I'm going to kind of keep working, going through this section, just because I'm trying to finish the stream. So, and also, just as a brief announcement, and I'll give more announcements a little bit later. We are doing online asynchronous. I take attendance as I let you into my Zoom, right? So that's why I need your Morehouse student name to show, because I'm looking for your name in my roster. If the names don't match, then that can create trouble. So the simple thing is just to show your Morehouse student name. Yeah, I figured that was you, because that was the one that was closest. So that's who I give the credit to. Yeah, it's no worries. That symbol was not the proper symbol. It just was a typo. That's not the greatest integer function symbol. The greatest integer function symbol was the symbol that you saw me write. So that was just the technology not displaying the proper symbol. That's all. Ooh, I've been talking nonstop. What is this? For an hour? Oh my god. This is intense. Okay, let's keep it going. Hence why I do my recordings, so that, we can all kind of be on the same page. Okay. So let me take some time to go ahead and finish out this section, and then, I'll give you guys, and I'm taking attendance as I speak. There was one that popped in and out. I'm going to take it off for right now so it comes back. Okay, I got him. And okay, cool beans. All right. But yeah, so what I'm doing right now, I'm just wrapping up this section. This is section 1.4, and I'm just wrapping it up. And we'll talk once I'm done with this presentation, and we get through attendance. Okay, I have one person here. Oh, there he is. I found him. We got a lot of students. These are really interesting names. Like, I want to ask them questions, but I don't want to put them on. I don't want to put them on blast. I think I got this student already, so I'm not going to worry about that. HIG. Okay, that looks good. All right, I kind of got this down, a little bit down. A little system going here, and we got another one. And again, I do want to, just say that this week we are doing online asynchronous. You're not required to stay. Once you get into my Zoom, that means you've gotten attendance credit for the day, and then I leave the rest up to you. I'm just making the materials available and making myself available. So give me a moment to finish going through this section, and then we'll pause at the end. I got a little ways to go to. I'm about halfway through, so I'll kind of be stopping periodically to kind of check the chat, and so if you have questions, either raise your hand or type it in the chat, and I'll respond then. Who we got? Yeah, that was the one that popped on earlier. Cool, that looks good. I can let him in. Okay, so let's look at this notion of what do we mean by basic functions. So the following are some of the common functions of algebra along with their properties and should be included in a library of basic functions. All right. Oh, are you slowing down on me? Doggone it. Let me reboot this. It'll take like a second. I think this will fix it. Let me see. Do I have anything? Okay. And it's here. Come on. Basic functions. Let's try this. Okay. I think it should be better. That looks better. So the first basic function that we want to discuss is called the constant function. So the domain of a graph is going to be the very left to the very right, right? So how far left does this graph go? What's the very, very far left? So the far left is going to be negative infinity. The far right is going to be positive infinity. So the domain of this should be negative infinity to positive infinity, right? The range is the very bottom to the very top. How far down does this graph go? How far up does this graph go? Well, this is a constant function, so it doesn't go up, nor does it go down. It stays flat or constant. So the range is just going to be whatever C is. We use curly brackets. Curly brackets just mean a discrete set, just that number. It's not an interval. Is this function increasing, decreasing, or constant? This function is what we call constant over the domain. It stays flat. So I'm just going to circle constant. Is this function even, odd, or neither? So you'd have to go back in the video earlier in this video. This function is even. Let me think about it. Yeah, right? Basically because it has y-axis symmetry. You can, if you evaluate f of negative x, you'll get back the original. So this function is even, which means we have y-axis symmetry, right? And here we have a type version of those results. Let's look at another basic function. I know you may or may not have context because we haven't talked about this together, but it is in my recording, so you do have to go back and make your way through those. That thing was actually pretty decent. Okay, domain, right? The domain of a graph is the very left to the very right. We ask ourselves, how far left does this graph go, right? How far left does it go? If we were way over here, can we touch the graph? Yeah, because it's going to be somewhere like way off the screen, right? So the far left, similar to the last one, the far left is negative infinity. The far right is positive infinity. The range, so the domain is the very left to the very right. The range is the very bottom to the very top. So how far down does the graph go? It goes down to negative infinity and up to positive infinity. So the domain and range are the same here. Okay, I see some activity in the chat. I'll address it momentarily. Is this function increasing, decreasing, or constant? So as we trace it left to right, is it going up, is it going down, or is it staying flat? The graph is going up. So we say that it's increasing over the entire domain. And then is there any kind of symmetry? Notice if we fold this on the y-axis, it doesn't add up. I think we do have origin symmetry though. So every time there's x comma y, we also have negative x comma negative y. We got another student. Let me give him credit. Okay, right here. Okay, I'm gonna let him in. So we have origin symmetry. So because it has origin symmetry, we say the function is odd. So origin symmetry and odd mean the same thing. So notice the domain and range is increasing. Did we talk about increasing? Yeah, it's increasing over the entire domain. It's an odd function, which means we have origin symmetry. Okay, I saw some activity in the chat. I'm going to pause for the cause for a moment and check the chat. Negative infinity. Thanks. Yeah. I should be using that to get some live interactions. I'm just keeping my own rhythm and flow. Let's keep it moving. Okay. So next we have the squaring function. We talked about the constant function, identity function. So now we have a squaring function. This is going to be y equals x squared, right? So the domain, again, of a graph is going to be the very left to the very right. How far left does this graph go? The far left is going to be negative infinity, and the far right, so it's the same as before. Let's paste. All right, so that's the domain. The range of a graph is going to be the very bottom to the very top. So how far down does this graph go? The very bottom, in this case, is going to be 0, right? And then how far up does it go? It goes up to positive infinity. Infinity always gets in parentheses. The range, it does such to 0, we can include 0. So it's going to get a square bracket. So increasing, decreasing are constant. As we trace the graph left to right, what is it doing initially? Is it going up, is it going down, or is it staying flat? So as we trace it left to right, initially it's going down, right? So we say it's decreasing. The far left is going to be from negative infinity up until what, 0? And for this concept, we just use parentheses across the board. And then on the other side of 0, it goes from decreasing to increasing. So we say it's increasing from 0 to infinity. Okay, and it's not constant anywhere. Is there any kind of symmetry? So even, another way of considering even means y-axis symmetry. So notice we can fold this on the y-axis. So this function is even. We have y-axis symmetry. Okay. Odd means origin symmetry. Whenever we have x comma y, we also have negative x comma negative y. This is not odd. And so we identified it as even already. And we said that it has y-axis symmetry. Okay. And we see those things that we just spoke on. We see it here. Okay. So another domain and range. In the graphical sense, domain is the very left to the very right. How far left does this graph go? Hopefully you can see that the domain is all reals. The range, the very bottom to the very top, how far down does the graph go versus how far up it goes, is the same in this case. As we trace it left to right, is it going up, is it going down, or is it staying flat? It's actually increasing over the entire domain. It looks like it flattens out. It almost does, but it doesn't quite flatten out in the middle. Is there any kind of symmetry? If we focus on the y-axis, the two halves don't match. Origin symmetry is almost like if you put your thumb on the origin and you cut it along the x-axis, and you take that top half and rotate it 180 degrees, that top half is going to match the bottom half. Or you can look at it as whenever we have x comma y, we also have negative x comma negative y. So in either case, this function has those properties. So this function is odd, which means origin symmetry. Origin symmetry. Okay. Okay, I think that's everything here. Okay. All right, the domain. How far left? The very left, the far left of this graph, the domain, so the very left to the very right is similar as before. It's going to be all reals. The range being the very bottom to the very top. The very bottom is what? Y equals 0, and the y values go all the way up to positive infinity. And we actually touched the 0, so this gets a square bracket. Okay, increasing, decreasing are constant. As we trace it left to right, what is it doing initially? Is it going up, is it going down, or is it staying flat? Okay, this is increasing from the far left being negative infinity up until 0. We use parentheses across the board. Then, sorry, not increasing, but it's decreasing in that part initially. First is decreasing, then it's increasing as from 0 to infinity. Okay. We do have y-axis symmetry, so we say that this function is even, which is synonymous with y-axis symmetry. Whew. Let me see the time. Man, I still need to talk for like almost another 2 hours, and I'm like losing my mind. I don't want to talk anymore. This is another reason I do the recording, so at least I get a clean version for people, and then if I'm exhausted, I'm like, look guys, we're gonna have to use my recordings or something of that nature. My dog is so attentive. I got food up here, she's just like all eyes on me. That's how she's acting. It's so funny. Let me check the chat real quick. Right here. 0. Okay. So that was a response to a question I had earlier. Okay, cool beans. All right. So I think that's good. I can't find any errors there. Okay. So this is the square root function. Another way to visualize, I think the student got, oh no, I must have a couple of those name. Anyway. So this is called the square root function. Another way to visualize the square root function is that this is basically the top half of a sideways parabola, right? So if we take a U-shaped graph, we turn it into the positive x direction, and we take only the top half of that parabola. That's what the square root function is, right? So the domain. The domain is going to be the very left to the very right. What's the far left, right? If we're looking at this graph, the far left is going to be 0. And the far right is positive infinity. Infinity always gets parentheses. For this discussion, we do reach 0, so it gets a square bracket. Range is the very bottom to the very top. How far down does this graph go? Which is 0. I see some activity in the chat. I'm about to go check it. And the very top is up to positive infinity. And same kind of argument there. As we trace this left to right, is the graph going up? Is it going down? Or is it staying flat? I hope everything is okay. That chat is going off the chains. I'm just going to finish this to complete my thought. We said that the function is increasing over the entire domain, so from 0 to infinity. For increasing, decreasing, and constant, we generally use parentheses across the board. Is there any kind of symmetry? If we fold it on the y-axis, it doesn't match. If we rotate it 180 degrees about the origin, it doesn't match. So this is an example of something we would say is neither even nor odd. Is this spelled right? I before E except neither? Yeah, that looks right. Neither. And there's no symmetry. Okay. Let me check the chat. Hopefully everything is okay, because it seems like y'all are losing your minds. Let me see what's going on here. Let's see what's going on. No. Okay. Why is there a bracket? Let's back up. Okay. Yeah, I muted the audio so I can focus, because I know if I'm listening, I get distracted real easy. So I know how to focus, and I have my ways of focusing so I can do what I need to do. Why is there a bracket next to the 0 in the range? There's a bracket because we actually touch the 0 and we can include it. So square bracket means we include that endpoint, versus parentheses means we don't include that endpoint. So that's that one. Yeah, that's laughing to my stuff. I'm going. Yeah, I muted you guys just so I can focus because the noises kind of distract me. Let me see if there's anything else. A new account to join this meeting. No worries. I got you in my attendance. It's all good. You're good to go. Blah, 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 blah. Where's the dude that had a question? Okay, I'm going to unmute for a moment because I know someone had a question. Are you there? Go ahead. No. This is 50 minutes. So if you need to go, like if you're in the 2 o'clock, you can go. It's totally okay. I'm just doing a continuous stream so I can get one clean version of this section. Yeah, but in a general, go ahead. Oh no, the class is over for like 2:50. If you're in that 2 o'clock class, you can go. Like you don't have to stay. In general, we're doing online asynchronous. So I'm available during class time. I'm just doing the lectures just to have a fresh version of these. But they're recorded, So if you leave and you want to watch them later, you can do that. Just as long as you're getting your attendance credit. Office hours are actually during class time. So like, I'm just getting ahead. But if you want to like ask questions, we can talk about it during. Like I'm going to be online now until about 5 o'clock, and I'm really just doing the lectures just so you can have a fresh version. But if you want to like talk about homework or anything like that, we can do homework too. Yeah. So yeah, that's the long and short of all of that. Um, yeah, but on any given session, again, we're doing online asynchronous, so all I expect you to do is just log in and get your attendance credit. Once you get your attendance credit, it's up to you if you want to stay or go. Right? I'm not gonna press that matter. I'm just gonna be available, during the scheduled times to answer questions. And I'm also going to make your materials available and just try to keep checking on you. But that's generally how we're going to do everything. Okay. Yeah. So I take attendance as I let each person into my Zoom class. So if you make it into my Zoom, that means you've already gotten your attendance credit. All right. Yep. So once you make it into my Zoom, because I take it. That's why I keep pausing because I'm taking attendance as I let people in. Yeah. Okay. Yeah, and sometimes I do mute you guys so that I can focus. If I find that it's like getting too out of hand, then I'll shut all that down. But you know, it's okay for now. Okay. Okay, I'm going to mute you guys again. Again, just either raise your hand or type in the chat if you have a question. I am trying to wrap this one up. I'm on slide. I just completed slide 45 of 62. And I think I have a 4 o'clock class. We're going to have to do an orientation, but that doesn't concern you guys. Okay, so I think we got through this one. And you see all of that stuff there. Okay. So this is called the cube root function. Like you see it at the top, the cube root of a variable. So the domain, the very left to the very right is what? All reals. Can I paste? Let me see. Awesome. So the domain is all reals. The range is actually the same. The very bottom to the very top. As we trace this left to right, is it going up? Is it going down? Or is it staying flat? It's actually increasing over the entire domain. Okay. Any kind of symmetry? Is there y-axis symmetry? If you fold this on the y-axis, do the halves match? No. Is there origin symmetry? If you cut it along the x-axis and put your thumb at the origin, and you take that top half and rotate it 180 degrees, do they match? I know that's a mouthful. Or in other words, whenever you have x comma y, do you also have negative x comma negative y? This is actually a yes. So this is an example of a function being odd, which is the same as origin symmetry. Okay. So again, this information, it can it's kind of interesting because Morehouse revamped their the requirements for college algebra. They kind of broke it up. Like what you guys are responsible for in 2 semesters, the students of the past has to do it in 1 semester. So I think that was actually a good move because it was overwhelming for a lot of students. So I like that move. So I'm just, I say that because it may seem like a lot of information, but I just want you to be aware that this is half of what students of the past were responsible for, right? And I think the rhythm is fine. And then, so I'm just talking at my comfortable rhythm and my comfortable pace, but I'm doing that because it's a recording and you can always pull it up later, go back over it. I would recommend sitting down with like a tutor or your classmates or somebody and like making your way through the lectures and sitting down with somebody, and you can work on the homework together too. It's totally okay. As long as the thing is, on my end, I just need you to submit your documents. On your end, you just want to be ready to defend yourself whenever this stuff pops up. Sooner or later, you're going to have to like sit down and say, okay, show what you learned, or if you learned anything at all. And as long as you can defend yourself, it's okay, right? You can, I guess you can consider me your defense against the dark arts teacher. I'm totally like just having some fun. Let me see what we got going on. No worries. I got your attendance. It's all good. You're here. You're here, present and accounted for. So we're gonna keep moving. Just being silly with that defense against the dark arts thing. Just having some fun. But no, for real though. Like I'm just being real. You do not have to stay. This is asynchronous. You got your attendance credit, so I'm just going to keep moving and grooving. These sessions are being recorded and live and streamed live on my YouTube channel. So, that's going to be the long and short of that. The stuff is available. If you feel comfortable going through it on your own, that's fine. If the timing is like kind of throwing you off, I would still recommend like linking up with the tutors and sit down with them and go through this stuff as well. Most things are going to be available. I'm trying to get as much information available as soon as possible so that anybody that wants to get ahead can get ahead, right? Right now, I'll get into the announcements momentarily. I have about a few more slides I'm trying to get through. I want to finish out this section and then we can have a conversation. Okay. So, but this is section 1.4 that I'm trying to wrap up. So here we have a reciprocal function, f of x equals 1 over x. Let's talk about the domain. Domain of a graph is going to be the very left to the very right. So I'm going to look at this one the following way. So the very left, come on. Let's go style, sticking it up. And let's actually do something like this. That's better. Okay. So now the very left, how far left does this graph go, right? So as we start making our way to the left, how far left does it go? The arrow means continue the pattern, right? So the far left is negative infinity. So every x is accounted for. All the x's are still accounted for. But then something happens when x is 0. It actually never reaches x equals 0, right? But then on the other side of x equals 0, all the x's are accounted for. So the domain of something like this is going to be basically everything except 0, right? So the domain of this function, the far left, is going to be negative infinity up until 0, or union or combined with the right side, everything on the right side of 0. Infinity always gets parentheses. Because we never reach 0, 0 gets parentheses, and we combine these two regions with that symbol in the center is called union. It just basically means combine the left with the right. It's a similar discussion for the range. The range is the very bottom. Let me see if I can just rotate this by 90 degrees. So the range, right? How far down does the graph go? It's a similar argument. The very bottom, it keeps going. You can't, we can't see further because of our limited, 3D minds or whatever. But the very bottom is negative infinity. Notice that it jumps over y equals 0, but then on the other side, it picks back up. So it's a similar discussion for the range here. The range is going to be the same thing as the domain in this case. Copy and paste. Okay. As we trace it left to right, notice that, is this function going up? Is it going down, or is it staying flat? As we trace it left to right, notice it's going down, 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 and it's still going down, 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 right? So we say it's decreasing. We're going to say it's decreasing over the entire domain, because at no point is it increasing. Okay. A little bit trippy, just a little, but you can do it. We are trying to expand our consciousness a little bit here. Any kind of symmetry, even is the same as y-axis symmetry. If we focus on the y-axis, do they match up? It's going to be a no, right? Origin symmetry is like, it's kind of like rotational symmetry where the top half, if you rotate it 180 degrees, it matches. Or in other words, whenever you have x comma y, you also have negative x comma negative y. So this function is odd. It has origin, which means that it has origin symmetry. Origin symmetry. Okay, let me check the chat really quickly. Chat looks good. Okay, we are missing a few, but it's okay. And I think we have all of those notions typed up here. Okay, almost done with this. Okay, so again, this symbol did not display properly, so let me rewrite it, which is this one. That one didn't display properly. It's supposed to be like this. Something like that. This is called the greatest integer function. Kind of like that, right? Okay. And so the graph of the greatest integer function looks like this. Okay. It's kind of like a step function. What's the domain? The very left to the very right, right? So you have to be aware that with this, the pattern continues in both directions, right? So can you find any x that's where it's not accounted for? With, like, for instance, say x were negative 3 points. Let's do negative 1.7, right? If x, let's go like, that's good. So if x were negative 1.7, which is about here, right? Can we find the corresponding y? Yeah, x is going to be negative 2, because remember, negative 2 is the integer to the left. If x were 3, let's do 3.2, right? 3.2 is here. The corresponding y should be 3, right? What about if x were 4.7 right here, right? If x were 4.7, the pattern will continue. There will be a bar here at 4. If x were negative 3.6, which is about here, the pattern would continue. There would be a bar here. You have to kind of use your imagination and be aware that the pattern continues, right? So every x is accounted for. So the domain in this case, hopefully you can see it by now, the domain is going to be all reals. Okay. The range is the very bottom to the very top. Now, as we go down, are all the y's accounted for? Can we find, are there some y's that aren't accounted for? For instance, say y is negative 3. Are there x's that correspond to that? Yeah, right here. Say y is negative 2. Okay. Can we find some y's that are not in this output? What about, say, something like, what if y was 2.5 right here? Is there an x that corresponds to 2.5? No. Any y value that's not an integer is not in this output, right? Only thing that's in this output are integers. That's why it's called the greatest integer function. So the range is actually going to be the set of integers. A little bit different. Is this function increasing, decreasing, or constant? I want to say it's constant. Oh, it's not the whole domain, but the function is constant, and you're going to write it like this. So that's not a t. And like the first one, what is this? Negative 3 to 2. So we could say like negative 3 to negative 2. The 3 gets a bracket. This gets a parentheses. Then we could say what? Negative 2 to negative 1, like this. And then just basically keep the pattern going in both directions, right? You just gotta, we're basically just trying to identify those segments, right? So we say it's constant on those. Is there any kind of symmetry? If we fold this on the y-axis, do the halves match up? No, right? If we fold this on the y-axis, they don't match up. Is there origin symmetry? If we put our thumb on the origin and rotate the top half 180 degrees about the origin, do they match up? Close, but not really. They don't, right? Because notice, if you follow this open circle and rotate it 180 degrees, it's going to end up right here. And even if they did match up, this is an open circle that's closed, it still don't match, right? So there's no origin symmetry as well. So it's neither even nor odd. little bit trippy, and there's no symmetry. Okay, let me get rid of this cursor just to kind of clean up some of the clutter. No more talking for me, please. I don't want to talk anymore. Not for a little while. Let's copy and paste. Okay. So it's neither odd nor even, and there's no symmetry. Let me check the chat. That was a little bit trippy. That's not a common expression. We just wanted to discuss it here. So why there's a question that pops up that says, why is the range the set of integers, right? So the range are the set of output values. So all the x's get output to what are the y values here, right? What are the y values? So the only y values that we have are the integers, right? So for instance, like if we consider y equals to 2.5, can we find an x that maps to y equals to 2.5? No. Can we find an x that maps to like 1.7? No, right? Because the y values is only defined for y equals 1, y equals 2, y equals 3, y equals 4, y equals 5, y equals 0, y equals -1, y equals -2. This function is only defined for the range is only defined for the integers, right? Hopefully that makes sense. That's about the best I can do with that explanation. Okay, let me see. I'm going to keep moving forward. We don't need this guy. Whew. Okay, moving along. So average rate of change. For the sake of simplicity, whenever you see average rate of change for our discussion, all average rate of change for our discussion is basically just the slope. It's just the slope between 2 points, right? So given a set of ordered pairs, let's do it like this. So given an ordered pair a comma f of a and a second ordered pair b comma f of b, be points on the graph of a function, the average rate of change of f of x as x changes from a to b is going to be defined by basically the slope function here, as long as a is not equal to b. So basically this is like y2 minus y1 over x2 minus x1, all right? Okay, so for our discussion, average rate of change is essentially the slope. This recording is long. Let me see. We've been going at it. I'm gonna just let it ride. Oh, the time is now 3:33. I don't know if you study numerology, but that's a good omen. Okay. Finding the average rate of change. We're asked to find the average rate of change of this function as x changes from 1 to 3, right? So basically they're saying find the slope between the ordered pairs. So all I'm going to do, I kind of want to generate some space, and I'm going to use the space that I have. So when x is 1, right? So we have this f of x equals 2 minus 3x squared. And we want to find the average rate of change as x changes from x equals 1 to x equals 3, right? So long story short, we're basically just going to find the slope that's created between those 2 points. So when x is 1, right? So let's consider f of 1. That's going to be 2 minus 3 times 1 squared. Okay. 2 minus 3 is what? -1. And then let's also consider f of 3. That's going to be 2 minus 3 times 3 squared, right? So what's that, 27? 2 minus 27 is -25. So this basically generates 2 ordered pairs for us. The first ordered pair is 1 comma -1. The second ordered pair is 3 comma -25. So again, whenever I get ordered pairs, I'm a fan of labeling them x1, y1, x2, y2. I started to use a slope formula, but let me use the rate of change formula. Rate of change is the same as slope, it's just a different way of saying it. It basically says, it's like f of b minus f of a over b minus a. We're going to do f of x2 minus f of x1 over x2 minus x1, right? That's average rate of change. So then f of x2, that's going to be -25 minus negative 1, notice my use of parentheses, over 3 minus 1. Negative 25 plus 1 is going to be negative 24 over 2, which is negative 12. So our claim is that the average rate of change as x changes from 1 to 3, the slope is going to be about negative 12. So it's a negative average rate of change. Okay, so again, long story short, the simple explanation is all we did was find the slope generated between the 2 points, the 2 ordered pairs. Okay, and you see the same result there, negative 24. Find the average rate of change of this function as t changes from 5 to not equal to 5. So we could, one way I'm seeing like we can approach this. So we can look at several ordered pairs, right? We can consider as t changes from like, you can do just several. I don't know. Like as t goes from 5 to, you can do like 6, and then you can do 5 to 5.5, and then 5 to 5.1, and then 5 to 5.01, and then 5 to 5.001. Instead of writing all those out and finding all those slopes, I would use like Excel or something like that to create a formula. Let's see what the text is doing. Find the average rate of change of this function as t changes to 5 to not equal to 5, okay? So they take the average rate of change formula. So they're basically saying the function minus when x is 5 over x minus 5, right? So then they plug the components in. So then f of x, they just took the function and they simplify it down. Ultimately, they get to this linear function here. Okay. Let's see. So then given any x value, they could find the slope generated, the average rate of change given any x other than 5. Okay, that makes sense. Okay, so that's fine. I'm just going to kind of let that be for the moment. We're almost done. I'm trying to finish this out before I take a break. Another break anyway. For a function f, this quantity is called the difference quotient, right? So where h is going to be some positive change, some change other than 0. So given this function, find and simplify the difference quotient associated with this function. Okay, so for something like this, you want to find the parts separately. Let's first focus on f of x plus h. So f of x plus h, we're going to replace each x first with a blank set of parentheses. So it's going to be 2 times x squared minus 3 times x plus 5. In this case, our x's are actually the x plus h's, right? So the blue part goes into each parentheses. So then when we expand it, we're going to get 2 times, we get x squared plus 2xh plus h squared, okay, minus 3x minus 3h plus 5. Here I distributed the negative 3. In the first part, I FOILed. I'm going to distribute this 2. Okay. That's going to be 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5. Okay. So that's the expansion of f of x plus h. It expands into all of this. So now for the difference quotient, we're going to say f of x plus h here. We're going to say f of x plus h minus f of x. Let's just go ahead and evaluate that. So then basically that's going to be all of this stuff. So let me just making a copy instead of writing all of that again. And I actually want to shrink it down. So just to make it a little bit more manageable. So we want to take the result from the previous and we want to say minus f of x. I'm going to go ahead and distribute my negatives. So that's going to be minus 2x squared plus 3x minus 5. I distributed the negative. I think we can combine some like terms here. The negative 2x squared cancels the positive 2x squared. We got a positive 3x cancels a negative 3x. We got a negative 5 cancels a positive 5. And so what that leaves us with, we got this 4xh plus 2h squared minus 3h. That's it. And then the final part is going to be f of x plus h minus f of x. So basically the answer that we got divided by h. Okay? So I'm going to copy and paste because I can. Copy and paste. And I want to divide that by h. Okay? Notice from everything on top, we can factor out an h. That leaves us with 4x plus 2h minus 3 over h. And these guys cancel each other out at this point. This cancels this. And just for the sake of space, I'm just going to box the final answer. This here is the final result. And again, I'm just doing this because I'm out of space. Style like this. Okay. It was an adventure. Let me see the time. Oh, and we are essentially there. Wow, I knew that was going to happen. Okay, let me wrap this up. Blah, blah, blah. They did the same thing. 4x minus 3 plus 2h. 4x minus 3 plus 2h. Looks good. We got the same thing. Okay, so that was an adventure. Okay, so I'm unmuting the audio so that if you feel like you need to speak up, feel free to unmute. My recommendation, go ahead and be making your way through the assignments on Pearson. Again, right now, the only thing that's available are the homeworks. I did go ahead and make all the homework for the semester available. So it's not going to be any more homework than what's already there. My recommendation, just go ahead and get as far ahead as you can. Sit down with the tutor, sit down with your classmates, and just get it submitted early. Because what's going to happen is the closer we get to midterms, all of your classes are going to be demanding like assignments due at the same time. So to minimize your stress at those times, I make this stuff available as soon as possible so you can get as far ahead as you feel like you need to maintain your sanity. Again, I would recommend seeking the tutors, reach out to the math department office, and they'll link you with the tutors. I would recommend sitting down with them for this information. That's the main thing. Everything else kind of works itself out from there. Like once you kind of get those things submitted on Pearson, everything else kind of works itself out. If there aren't any burning questions, let me check the chat. What's the final answer for the one? If you're talking about that one with the integers, that was just asking about range. So it was just properties of this graph. We just kind of discussed, the domain of something like this. We discussed the range of something like this, and then any kind of symmetry and whether the function was even, odd, or neither. Right, the last one. Okay, let's look at the last one real quick. Right here, the final result is that 4x plus 2h minus 3. You see it here, 4x minus 3 plus 2h is the same thing. Right. Main thing is just getting your assignment submitted on Pearson. If there aren't any burning questions, have a great weekend, guys. Be on the lookout for some quizzes. I'm going to get as many quizzes loaded as I can. They'll be quick, but they'll be more indicative of what you can anticipate in the exams as far as the style. Okay. If there aren't any burning questions, have a great weekend, and I'll see you guys on Monday. Same place, same time. Okay. Peace. I'm going to go ahead and stop the stream. OBS.